Now that you have learned about Dart and OOP concepts, it is time to move forward and prepare your machine for building and running Flutter apps. In this lesson, we will walk you through setting up your Flutter development environment on Windows step by step. By the end, you will know exactly how to install and configure all the tools needed to start building your apps confidently. You will learn how to install the Flutter SDK and add it to your path, install and configure Android Studio, install Flutter and Dart plugins, accept Android SDK licenses, connect a device or set up an emulator, and use the Flutter Doctor tool to ensure everything is ready to go. Welcome to Flutter Development on Windows. Setting up your development environment properly will save you a lot of frustration later. This section will guide you step by step, ensuring you have everything ready to start coding and testing your Flutter apps with ease. To start, you need to download the Flutter SDK. Head over to Flutter's installation page and download the Flutter SDK zip file. Once downloaded, extract the zip file to a location on your computer. For example, see Flutter. It is best to avoid extracting it to locations that require admin privileges to prevent permission issues during development. Next, you need to add Flutter to your system's path, so you can use Flutter commands globally. Search for environment variables on your Windows machine. Select Edit the System Environment Variables, and then click on Environment Variables. Under System Variables, find and select Path. Then click Edit, and then New. Add C, Flutter, bin. Click OK on all dialogues to save your changes. After this, open a new command prompt or PowerShell window for the changes to take effect. Next, we will install Android Studio, which is the recommended IDE for Flutter development. Download it from the Android Studio website and proceed with the standard installation. This will include the Android SDK and the AVD Manager, both essential for building and testing your Flutter apps on Android devices and emulators. Once Android Studio is installed, you need to install the Flutter and Dart plugins to enable Flutter development within the IDE. Open Android Studio, navigate to File, Settings, Plugins. Search for Flutter in the marketplace and install it. The Dart plugin will be installed automatically along with Flutter. After installation, restart Android Studio to apply these changes. Now, you need to accept the Android SDK licenses required to build and run Flutter apps on Android devices and emulators. Open your terminal and navigate to your Flutter path using cd c Flutter, or the location where you extracted the Flutter SDK. Then run Flutter Doctor --Android -licenses. Follow the prompts to accept all the licenses. Now that your environment is set up, it is time to connect a device or set up an emulator for testing your apps. If you want to use a physical Android device, enable USB debugging in your phone's developer options. Then connect it to your computer via USB. Alternatively, you can set up an emulator using the AVD Manager in Android Studio. This will allow you to simulate different devices and screen sizes while testing your Flutter apps. Once your environment and device or emulator are set up. It is time to verify that everything is ready using flutter doctor. Run this command in your terminal, and it will check your environment setup for any missing dependencies or issues. If any issues are reported, follow the instructions provided to fix them before you continue building your apps. Let's see this in action with a quick demo prepared by one of our experts.
In this video, I'm going to show you how to set up your computer so that you could develop Flutter apps. I'm going to assume that you already have Android Studio installed and running correctly on your machine. We're going to open up our browser and Google search download Flutter. The page we're looking for is flutter.dev. We're going to click on Get Started. Then we choose our operating system. Then we choose the type of apps we're going to be building. I'm choosing Android. We scroll down until we find the download button for the zip file and click on it to start the download process. Once the download is complete, we extract the contents of the zip file. You can extract them to anywhere you like, but usually we extract them into a folder called Flutter that we create inside of our C directory. So I'm going to open local disk C, create a folder called Flutter. Then I'm going to go back to downloads. Then I'm going to extract into the folder we just created. Once the extraction is complete, we open up the folder. Inside the folder, you're going to find another folder called bin. We're going to go into that. Then we're going to copy the location of this folder. The next thing we're going to do is make sure that the downloaded files are correctly working. To do this, we're going to open up command prompt. We're going to cd into the directory we just copied. That is the bin directory. Then we're going to run flutter doctor. The flutter doctor command is a diagnostic tool provided by the Flutter SDK. Its primary purpose is to inspect the local development environment and identify any missing dependencies or configurations required for Flutter development. Most things seem to be working, but it is giving us one error. It says some Android licenses not accepted. To resolve this, run flutter doctor -- Android licenses. We'll come back to this later because before that there is something we need to do. Right now, if we opened up command prompt and run flutter doctor, it's going to tell us that it does not recognize the command flutter. This is because it does not know where the Flutter executable exists. In other words, we have to tell command prompt that it needs to look inside the bin folder. To do this, we're going to open up control panel and then search for edit system environments. You could also search for edit system environments directly from the Windows search box. We're going to click on environment variables. We're going to choose path and then we're going to choose edit. We're going to click on new and then we're going to paste the bin directory address that we copied from earlier. Now if we open command prompt, and type in Flutter Doctor, you could see that it's working. Let's now go ahead and fix the issue from earlier. It's telling us that we need to run Flutter Doctor --Android licenses. So let's do that. It's telling us that there are 7 SDK package licenses that we have not yet accepted, and if we want to review them. I'm going to type in Y and press enter. We can accept these licenses by pressing Y and enter. Let's run Flutter Doctor one more time to see that everything is working. So no issues found. This means that Flutter is successfully installed on our machine. The next thing we're going to have to do is install the Flutter plugin into Android Studio. So we're going to open up Android Studio. We're going to go to the plugins section. Make sure you're on the Marketplace tab and then search for Flutter. We're going to click on Install. Once it's done installing, it's going to prompt us to restart the IDE. It needs to restart the IDE so that the plugin could start working. Now that Android Studio is restarted, you could see a new button at the top that says New Flutter Project. We're going to click on that to create a new Flutter project. The first thing we're going to need to fill out is the SDK path. Remember that this is where we unzipped Flutter, so for me it was inside of local disk C, Flutter, and then Flutter. Then I'm going to click on Next. It's prompting me to name my project. When it comes to naming Flutter projects, you cannot use spaces, so I'm going to do Flutter_practice for my project name. You could also choose where your project files are going to be located. You could give a description to your app. You could decide to either program in Java or Kotlin. You could also decide which platforms you want to support. I'm going to leave everything as is and then click on Create. I'm going to run a virtual phone that I previously created to test my Flutter app. So I'm going to go to the device manager and click on the play button that's next to the device's name. Then I'm going to choose my phone from the list of choices and click on the green play button at the top. This is going to build my project and install it on my virtual phone. You could see that the app has an app bar with the title Flutter Demo Homepage. In the middle there's some texts, and at the bottom there is a floating action button. If you click on the floating action button, it will increase the count. To double check that everything is working correctly, we're going to change the title in the app bar. So let's search for Flutter Demo Homepage inside the code. And then let's change that to My Flutter App. And let's click the Run button again. And you could see that the app bar title has changed. This means that Flutter is successfully installed on your computer and it is successfully integrated into Android Studio, and you can now develop Flutter apps on your computer.
When creating your first Flutter app, click on New Flutter Project and name your project something like Hello. Check on the Create Project Offline for Flutter. After you've created the project, change the folder structure to project files and open main.dart. If it's not already opened, you will see a different code from this. And the next step you'll do is start your virtual emulator. And select your device of your virtual mobile phone from the list. Next, you will click on the Run Project button. This will launch your Flutter app. Currently, I have set up a bare minimum line of code. It's going to be a black screen. And to make some change, let us add a home of scaffold. Inside it, I'm creating a body with the child at position center of the screen. Hello Flutter. If you run the code now, you will see on the virtual emulator, Hello Flutter.
Let's summarize the key steps you have learned in this module. You downloaded and extracted the Flutter SDK zip file. You added the Flutter bean directly to your system's path environment variable. You installed Android Studio, including the Android SDK and AVD Manager. You installed the Flutter and Dart plugins within Android Studio. You accepted the Android SDK licenses using Flutter Doctor --Android licenses. You connected an Android device with USB debugging enabled or set up an Android emulator. Finally, you ran Flutter Doctor to verify your setup and resolve any reported issues. Before we move on, take a moment to reflect on these questions to reinforce your learning. What are the essential tools for Flutter on Windows? And how do you install and configure them? What does Flutter Doctor do? And how do you fix common issues it reports? Why is Android Studio recommended? And how do you set up an emulator? What extensions are needed for Flutter in VS Code? And how do you configure it? Where do you find official Flutter resources? And what is a common command to resolve Android license issues? Pause here to consider your answers, as these will help you confidently troubleshoot and manage your development environment as you start building projects. If you would like to go deeper and solidify your understanding of Flutter setup on Windows, here are some recommended resources for you. These resources will help you explore additional details, learn common troubleshooting techniques, and ensure you are well prepared to handle your Flutter development environment efficiently. Thank you. Now that you have learned how to set up your Flutter development environment on Windows, it is time to prepare your macOS environment for Flutter development. This lesson will guide you step by step through the Flutter setup process on your Mac, so you can start building and testing Flutter apps confidently, whether you plan to target Android or iOS devices. By the end of this lesson, you will be able to install the Flutter SDK and add it to your path, install and configure Android Studio, install the Flutter and Dart plugins, accept Android SDK licenses, connect a device or set up an emulator, and use the Flutter Doctor command to check that your environment is ready. Welcome to Flutter development on macOS. Setting up your environment correctly is essential to ensure a smooth development experience. In this section, you would follow a clear, structured process to get everything ready for your Flutter learning journey. To begin, you will need to download the Flutter SDK. Go to Flutter's official installation page and download the Flutter SDK zip file. Once the download is complete, extract the zip file to your preferred development folder. A common location for this is development Flutter. Next, you need to add Flutter to your path so that you can access Flutter commands from anywhere in your terminal. Open your terminal, then open your shell configuration file. If you are using ZSH, type nano tilde /.zshrc. If you are using Bash, type nano tilde /.bash_profile. Inside this file, add the following line. Export path equals path/development/flutter/b. Make sure to replace the path if you extracted Flutter somewhere else on your system. Save and close the file. Then run source_.zshrc or source_.bash_profile. This will apply your changes so you can start using Flutter commands immediately. Now you will install Android Studio, which is the recommended IDE for Flutter development. Download it from the Android Studio website and follow the installation steps, choosing the standard installation. This will include the Android SDK and the AVD Manager, which you will use to manage your Android emulators. Once Android Studio is installed, open it and navigate to File, Settings, Plugins. In the Plugins section, search for Flutter and install it. The Dart plugin will be installed automatically with Flutter. After installation, restart Android Studio so your IDE is ready for Flutter development. Next, you need to accept the Android SDK licenses to ensure your Flutter projects can build and run properly on Android. Open your terminal, navigate to your Flutter directory using cd:/development/Flutter, or the path you chose for your Flutter installation. Then run the following command: flutter doctor --android-licenses. Follow the prompt in your terminal and accept all the licenses provided. Now, let's prepare for testing your apps by connecting a device or setting up an emulator. If you prefer using a physical Android device, enable USB debugging on your device through the developer options. Then connect it to your Mac using a USB cable. If you prefer using an emulator, open Android Studio and use the AVD Manager to set up and configure an Android emulator. This will allow you to test your apps on various device configurations without needing a physical device. Once your setup is complete, it is time to check if everything is ready using Flutter Doctor. Open your terminal and run this command. Flutter Doctor will scan your environment for any missing dependencies or configuration issues and will provide you with clear instructions to fix them if needed. Make sure to address any reported issues before you start building your apps to ensure a smooth development experience. Let's quickly recap what you have accomplished in this module. You downloaded and extracted the Flutter SDK zip file. You updated your path environment variable to include Flutter's bin directory. You installed Android Studio, including the Android SDK and AVD Manager. You installed the Flutter and Dart plugins in Android Studio. You accepted the Android SDK licenses using Flutter Doctor --Android-licenses. You connected a device with USB debugging enabled or set up an Android emulator. Finally, you ran Flutter Doctor to verify your environment and fix any reported issues. Before we move on, take a moment to reflect on these questions. What are the core tools needed for Flutter on macOS, and what are the key installation steps for each? How do you use Flutter Doctor to verify your environment, and what are common macOS specific issues it might reveal? Why is Xcode important for Flutter development on macOS, and how do you configure it for iOS simulators? What are the essential Android Studio configurations for macOS, including setting up simulators? Where are the primary Flutter resources for macOS developers, and what is the command to resolve any Xcode licensing issues? Thinking through these questions will help you reinforce your learning and prepare you for your practical setup work. If you would like to deepen your understanding of setting up Flutter or macOS, here are some recommended resources for you. These resources will guide you through troubleshooting, advanced configurations, and understanding environment management to strengthen your Flutter workflow on macOS as you progress. Thank you for. Now that you have set up your development environment, it is time to start understanding how Flutter apps are actually built. In this lesson, we will explore Flutter widgets and layouts, which are the foundation of everything you see in your app. By the end of this lesson, you will understand what widgets are, differentiate between stateless and stateful widgets, learn how to create them, and understand the role of the build method in rendering your UI. Let's begin by understanding what a widget is in Flutter. Widgets are the fundamental building blocks of Flutter user interfaces. Every visible element you see in your app, and even the invisible structures that hold these elements together, are widgets. You can think of them as the Lego bricks of your app's interface, letting you piece together complex UIs in a clear, modular way. Flutter uses a declarative UI approach, which means you describe what your UI should look like in its current state, and Flutter takes care of rendering and updating it when your app state changes. This approach makes your UI development more predictable and easier to manage. Another important concept is immutability. Once you create a widget, its properties cannot be changed directly. If you need to update the UI, like changing text or colors, you create a new widget with updated properties. This immutability is key to maintain performance and stability in your Flutter apps. Widgets are arranged in a widget tree. Widgets are nested inside each other, forming a hierarchical tree-like structure where the root of this tree is the main widget of your app, and this hierarchy determines how your widgets are displayed and related to each other. Now that you understand what widgets are, let's look at the two main types of widgets in Flutter: stateless and stateful. Stateless widgets are immutable, meaning their properties are fixed when they are created and do not change afterward. You can think of them like a snapshot of your UI, perfect for displaying static information or elements that do not need to update dynamically. Common examples include text, icon, and image widgets, as well as layout widgets like row and column, when their configuration is static. The heart of a stateless widget is the build method, which takes a build context to provide information about the widget's position in the tree and returns the widget that will be rendered. Here is an example. In this example, the myText widget receives a text property when it is created, and it uses the build method to display that text on the screen. Next, let's explore stateful widgets, which allow your app to manage and update data that changes over time. Stateful widgets themselves are immutable, but they create and manage a state object that holds the mutable data for that widget. This structure allows your UI to update in response to user input or other events, making it perfect for interactive components, animations, and anything that needs to update dynamically. Some examples of stateful widgets include checkbox, text field, slider, and animated container. The structure of a stateful widget involves two parts: the stateful widget class, which defines the widget's configuration and creates the state object, and the state class, which holds the mutable data and manages the UI updates using the setState method. Here is an example. In this example, Pressing the button will increase the counter and update the displayed value, demonstrating how state changes trigger a UI rebuild. Let's see this in action with a quick demo prepared by one of our experts.
Stateless widgets are immutable, meaning their properties are fixed when they are created and do not change afterward. You can think of them like a snapshot of your UI, perfect for displaying static information or elements that do not need to update dynamically. The heart of a stateless widget is the build method, which takes a build context to provide information about the widget's position in the tree and returns the widget that will be rendered. Next, let's explore stateful widgets, which allow your app to manage and update data that changes over time. The structure of the stateful widget involves two parts: the stateful widget class, which defines the widget's configuration and creates the state object, and the state class, which holds the mutable data and manages the UI updates using the setState method. I am creating a counter that will update when you click a button. We set state to modify counter every time increment function is called. Our elevated button will have onPressed call of the increment counter function and a child that will be the name of the button, a text increment. Thus, when you click on increment, you can clearly see that counter is updating and changing. If you press Shift plus F10 to run the app, the state will be lost and you'll start from 0. If you use hot reload, it will save the state and make any change in your code, and the state will be kept. The shortcut command is Ctrl \. In clicking on increment, you see it continues from where we paused.
Let's compare stateless and stateful widgets to reinforce your understanding. Stateless widgets are immutable. Their properties do not change, and they are used for static content. They describe what the UI should look like without managing any data changes. Stateful widgets, on the other hand, can manage mutable data, allowing the UI to update when the state changes. They are used for dynamic content and interactive features, using the setState method to notify Flutter when changes occur. Here is a quick summary of what you have learned in this lesson. Widgets are the UI building blocks in Flutter. Widgets are immutable, meaning they do not change directly. Instead, new widgets are created with updated properties when needed. Widgets are organized in a widget tree, forming the structure of your app's UI. Stateless widgets are used for static content and use the build method to describe the UI. Stateful widgets are used for dynamic content and interactions, using a state object to manage data changes and the setState method to update the UI. The build method is central in both types, returning the widget to render on the screen. Remember, stateless is best for static content, while stateful is essential for dynamic and interactive content. Take a moment to reflect on these questions to solidify your learning. What is a widget in Flutter? Why are widgets immutable? When should you use a stateless widget? When should you use a stateful widget? What is the purpose of the setState method? What is a widget tree? Thinking about your answers to these questions will help you confidently recognize and use this concept when building your Flutter apps. If you would like to explore Flutter widgets and layouts in greater depth, here are some recommended resources. These resources will help you practice building widgets, understand more advanced layouts principles, and strengthen your confidence in creating well-structured Flutter UIs. Thank you. Now that you understand what widgets are and the difference between stateless and stateful widgets, it is time to explore basic Flutter widgets and layout techniques to start building real, structured user interfaces. In this lesson, you will learn the key properties and usage scenarios of essential widgets like text, image, and icon. You will master using layout widgets like row, column, container, and padding to arrange these elements effectively. You will also learn how to display scrollable lists and grids using list view and grid view in your Flutter apps. Let's begin with basic widgets, which are the essential building blocks for displaying content in your apps. The text widget allows you to display text on the screen. The data property holds the actual text you want to display, which is required. You can customize the appearance using the style property with a text style object, allowing you to adjust font size, color, weight, and font family. Here is an example. You can align text using the text align property, limiting the number of visible lines with max lines, and handle overflow using overflow with options like text overflow .ellipsis to add an ellipsis when the text exceeds the available space. The image widget allows you to display images in your app in various ways. You can load images from your app's assets using image.asset, assets/myimage.png. To load an image from a URL, use image.network followed by a URL. To load images from local files, you can use image.file, brackets. You can control how the image fits within its container using the fit property with options like boxfit.cover or boxfit.contain, and set explicit width and height using the width and height properties. The icon widget allows you to display icons easily in your app. You can use built-in icons from the icons class, such as icons.home or icons.favorites, or load custom icons from your project assets. You can customize icons using the color and size properties to fit your design needs. For example, icon, icons.favorite, color, colors.red, size 30. Now that you know how to display content, let's explore layout widgets to arrange your widgets effectively on the screen. The row widget arranges its children horizontally in a single line. You can control horizontal alignment using the main axis alignment property with options like main axis alignment.start, main axis alignment.center, or main axis alignment.space between. For vertical alignment within the row, you can use the cross-axis alignment property. The column widget arranges its children vertically in a single line. Similar to row, you can control vertical alignment using main axis alignment and horizontal alignment within the column using cross-axis alignment. The container widget is versatile and allows you to style and position your child widgets. You can set dimensions using the width and height properties and change the background color using the color property. To add space inside the container around the child, use the padding property, while margin adds space outside the container. You can apply decorations like borders, shadows, and gradients using the decoration property, and align your child within the container using the alignment property. The padding widget adds space around a child widget to create separation between UI elements. You can use the padding property with an edge insets object to specify padding on all sides or individually for top, bottom, left, and right. For example, padding, colon, edge insets.all 16.0, child, colon, text, padded text. Sometimes you will need to display scrollable content, and for this, Flutter provides list view and grid view. The list view widget displays a list of children that can be scrolled vertically. For long lists, using listview.builder is efficient because it creates children on demand, saving memory and improving performance. You will need to provide an item count and an item builder function to build each item in the list dynamically. The grid view widget allows you to display children in a grid format. Using gridview.count, you can specify the number of columns and the children will automatically size to fit within the grid. For more control, you can use gridview.builder, which allows you to customize child sizes, spacing, and rendering efficiency. Let's see this in action with a quick demo prepared by one of our experts.
Create a Flutter app with the command line tool. Flutter SDK can create you an app by typing in Flutter create an app name. You change directory to the app and you type in Flutter run to run your Flutter application in an emulator. This will get you the same result like creating an app using the GUI. For now, let us clear out all the starter code and create an app bar in the scaffold. You will see that the text in background is set. And let's create a text with font size of 20 and a padding and centered. Now let's import DO package. This package helps us connect to APIs. Follow the step of installing it in PySpec YAML. If the API we request needs an authentication header, use the DO interceptor. The interceptor will catch all requests that's being made by the app and add a header like authorization header with bearer token, and here you would provide your API token. Then it will release the handler to the next operation. For the example URL, I'm going to use an API that doesn't require authorization. Thus, I'm going to go into my stateful widget that I would create by my DO widget. And first initialize our DO package, set a loading state. Fetch data function, setting the loading to true, and inside our try and catch statement, wait for the DO to fetch us a JSON response from a dummy URL and set our response data to the response of our fetch. And if we find an error, the response data text element is going to show us the error. Then finally, we set the loading state to false. To build our widgets, we use an elevated button, which will trigger our function, fetch data, and we give some spacing with size box for a good UI. And if the loading state is true, we have a circular progress indicator. If it's false, we have an expanded widget with scroll view, since we might have a lot of response, and a text aligned at center. Change the default Hello Flutter text basic widget into my DO widget. Running the application now. You can go on and click fetch data. It will create the circular indicator. And once it's done, we have our response of the news.
Let's summarize what you have learned in this lesson. You explored basic widgets like text, image, and icon for displaying content in your app. You learned about layout widgets like row, column, container, and padding to arrange and style your UI effectively. You discovered scrollable widgets like List View and Grid View to display scrollable lists and grids. You also understood that Flutter layouts rely on the widget tree structure and that customization happens through each widget's properties. Take a moment to reflect on these questions to strengthen your understanding. How can you change the font size and color of a text widget? What are the different ways to load an image in Flutter? How can you control the alignment of children within a row? What is the difference between padding and margin in a container? When should you use listview.builder instead of a regular list view? Pause here, think through your answers, and note any parts you would like to explore practically during your practice sessions. If you would like to explore Flutter widgets and layouts further, here are some recommended resources. They will help you practice building clean UIs, understand advanced layout strategies, and give you hands-on exercises to reinforce what you have learned in this lesson. Thank you for completing this lesson. You now have the foundational knowledge to build structured, visually appealing user interfaces in Flutter using basic and layout widgets, while understanding when to use scrollable widgets for your content. Take your time to review and practice these concepts, and I look forward to guiding you in the next lesson as you continue your Flutter development journey.